In this video, we're going to look at solving trig functions or trig equations, and part of that is being able to determine the exact values of different trig expressions. So in common language, what I'm saying is, hey, do you know what sine of pi on 6 or cos of pi on 3 or tan of 45 degrees, etc. is equal to in exact value solutions. Now, we're obviously going to need to be using something called the unit circle, and in our case, we're also going to be using exact value triangles or magic triangles, depending on what you call them. And if you need a refresher on that, you should probably go watch a quick little video on the unit circle, because the one that I'm going to be drawing is going to be quite small and not really a full depiction of what you would be used to seeing. All right, let's get into it. Now, like I said, for each of these, I'm going to be drawing a quick little circle like this. And I'm just going to have my 4 quadrants. And the whole purpose is I need to think about what the base angle is, pi on 3. And therefore, I'm going to put that over there, pi on 3. And therefore where 2 pi on 3 sits. And the reason I'm doing that is the magnitude of my answer is always going to be determined by this quadrant. So what I mean by magnitude is size. So if I'm a half or a negative half, that half, for example, is always determined by that top right quadrant. So let's have a look at this. It is pi on 3. Now, this is normally where 0 is, this is where pi is, and pi on 3 is the same as 60 degrees. So if you would like to use exact value triangles, and you can sketch these out yourself at the beginning of any of these questions in your exam, could be the first thing you sketch, and you can label what these sides are equal to. We'll do the other one as well. We'll do the 45 degree one. Now, degrees. They don't have to be amazingly drawn, they've just got to be usable. So pi on 3 is 60 degrees, so I'm going to highlight this. Pi on 3 is 60 degrees, and we are looking at cos. So what that means, cos is adjacent over hypotenuse, so 1 over 2. So we know that pi over 3, or cos of pi over 3, is normally a half, but we are now in this top left quadrant. Now, cos represents the horizontal axis, so I'm going to write that here. Cos is left to right, and sine is all about top and bottom, or up and down, the vertical axis. Now, we're normally over here at a positive half, but I'm now over here on the left, which means if we think about this as an x-axis, that means my answer is now going to be over here at a negative a half. So what I would say for A is cos of 2 pi on 3 is equal to negative a half. Let's get rid of some of this highlighting, get ready for the next use of it. Okay, so next question. This question wants us to do something with tan. Now, I'm actually going to avoid part B for now. I'm going to come back and I'm going to do B at the end. Let's do C, seeing as we just did a tan question. So let's do that in blue here. We've got negative pi on 6. So I'm going to draw it again. So pi on 6, I'm going to draw the normal one. Negative pi on 6 down here. Now, pi on 6 is 30 degrees. So I'm looking up here. And we have cos, which is adjacent over hypotenuse. So I already know for C, my answer is going to be root 3 over 2. The only question we've got to ask ourselves are we on the right-hand 2 quadrants, aka is my answer positive, or am I on the left-hand quadrants and my answer is negative? Well, looking at these quadrants, it's pretty clear to see over here, I'm on a right-hand quadrant. So we can say that cos of negative pi on 6 is equal to root 3 on 2. remove some highlighting again. Let's go different color. D. I've now got 11 pi on 3. So this circle might be a bit more trickier. 11 pi on 3. Well, that's, I'll do it in blue highlighter. That's 0 pi on 3. That's 3 pi on 3. Then we've got 6 pi on 3. 9 pi on 3. And then we are at 11 pi on 3. That's a lot of pi on 3s. Essentially, we need to have a think about what this looks like in terms of the number of rotations. Okay, so 6 pi on 3 is the same as 2 pi. That's a full rotation. Now we've got more than 6 pi on 3. We've actually got 6 pi on 3 plus another 5 pi on 3. So my answer for 11 pi on 3 is going to actually be the same as whatever my answer is for 5 pi on 3. So 5 pi on 3, it's clearly a base of pi on 3, so I'm going to put my base up here as pi on 3, and then all the way over here is going to be 5 pi on 3. I'm going to get rid of some of this out of the way. Okay, so if that's where 5 pi on 3 is, hey, like we said before, that means that's the same as 11 pi on 3. Okay, now pi on 3 is 60 degrees. Let's go back over to my 60 degrees, and we are talking about sine. So sine means opposite over adjacent. So my answer here is going to be sine of 11 pi on 3 is equal to root 3 on 2. The only thing we have to ask ourselves is, am I in a top side quadrant and my answer is positive, or am I a bottom side quadrant and my answer is negative? Well, looking at that, clearly I am in a bottom side quadrant, which means my answer is going to be negative. Alright, now we are doing question E. I'm going to go back to a green pen. So E, 7 pi on 3. Now, as soon as these angles are starting to have really big numerators, it does get a little bit trickier. So again, let's think about it like we said before. 0 pi on 3s, 3 pi on 3s, then back here again for 6 pi on 3s, in other words, 2 pi. So how much more are we than 2 pi? Well, we're just pi on 3 more. So again, when normally it's a pi on 3 standard angle, that's our denomination that we have, except we're not at pi on 3, we're at, we're at 7 pi on 3, which, well, that's the same angle. So, pi on 3, as we said before, is 60 degrees. We're talking about sine. So sine of 60, if I didn't erase it all, sine of 60 is root 3 on 2. So we would say sine of 7 pi on 3 is equal to root 3 on 2. Again, all we've got to think about now is it in the top half quadrant and your answer is a positive, or is it in the bottom quadrants and your answer is a negative? Well, clearly we're in the top side, we're at the exact same position as pi on 3, so that means my answer is positive. So I'm just going to leave it as it is. Now, I skipped over B before, so we're going to actually come back to B right now. I'm going to try to get rid of this highlighting without erasing everything again. Alright, now B wants tan. We want tan 7 pi on 4. Now, tan doesn't have one simple answer. Tan is made up of sine and cos. So tan of 7 pi on 4 is sine of 7 pi on 4 divided by cos of 7 pi on 4. So what we're going to do is a very similar process to before. Let's go over here. Let's think. It's a base of pi on 4. So this is 0. Up here is pi on 2. So over here, pi on 4. That's our 45 degree. So now we need to think, where is 7 pi on 4? Well, that's 1 pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4 down here. So 7 pi on 4. So again, that's our standard up here. We are down here. You can get rid of the other red ones. All right. So we have to think, what is sine of 7 pi on 4 normally equal to? Well, let's not overthink it. Pi on 4 is 45 degrees. So pi on 4, we're talking about sine, and we're clearly talking about 45 degrees. So sine is going to be opposite over hypotenuse. So this sine part of it is going to be root 2 on 2. Let's think about the magnitude. Is my 7 pi on 4 in the top quadrants or the bottom quadrants? It's in the bottom quadrants here, so it's going to be negative root 2 on 2. So that's what the sine part of my answer is going to be equal to. Now, let's think about cos. Cos, we're still looking at the 45 degree here. So the cos part is adjacent over hypotenuse. So root 2 on 2 divided by, well, root 2 on 2. This is good. We know our answer is going to be it's going to be 1. It's just whether it's negative or positive, because you've got the same number divided by the same number. So cos, am I in the right-hand quadrant? And my answer is positive, or am I in the left-hand quadrant? I'm in the right-hand quadrant, so my answer is positive, so I can leave it as it is. Now, there's one negative. I've got the same number divide the same number, so my answer is going to be negative 1. So we can say over here, tan of 7 pi on 4 is equal to negative 1. Now, if this wasn't the same number, like this, the same number divide the same number, and we actually needed to do some rearranging, we would have to remember our junior math skills of, you leave the top fraction the same, you turn this divide into a multiply, so that divide becomes a multiply, and then this fraction on the bottom here, you flip upside down, 2 over square root of 2. And again, the whole reason this is going to work and become the same answer, this root 2 and this root 2 are going to divide and cancel out. And then you've got this 2 and this 2 are divided and going to cancel out. And you are going to get negative 1 again. Okay. Now, why would you want to use this sort of skill here? Well, maybe it's a different angle instead of pi on 4. As soon as it's going to be an angle like pi on 3 or pi on 6 as the denomination, the solution is going to get a little bit trickier. All right. Let's have a look at this next example below. So now we know how to get exact values for different trig expressions, for different cos and sine of different angles. Now we have to be able to rearrange these trig functions and then think about the reverse of what we just did. So what we've done is, when we're given an angle, so when we were given these angles, we could work out the exact value. So now we've got to think the other way around. When we're given an exact value, what would that angle be? Let's get into it. Root 2 cos x plus 1 equals 0. Now, I'm going to rearrange these every single time so I can get sine x equals, cos x equals, tan theta equals, whatever it is. I just want the sine, the cos, the tan on its own. So root 2 cos x, take 1, I'll just move the plus 1 over, cos of x equals negative 1 over root 2, and then I'm going to rationalize the denominator. So what that means is I'm going to times the top and the bottom. I'm going to multiply the top and the bottom here by root 2 over root 2, and that is going to give us negative root 2 over 2. Now we just did an example with root 2 over 2, and we know that happens at the pi on 4 denomination. So where is cos a negative? Well, like we just said with every single one of these unit circles, I'll draw a quick little one off to the side. We're at a pi on 4, and we have to be somewhere in the left quadrants. Why does it have to be a left quadrant? Why does it have to be one of these quadrants over here? Well, our answer is a negative. So our answer could be, it could be over here as 3 pi on 4, or it could be down here as 5 pi on 4. So in this case, let's have a look at what our domain says. Our domain in our question specifically says from 0 to 2 pi. Well, that means that we've actually got two solutions. It means that our x could be 3 pi on 4, or x could be 5 pi on 4. Either one of those is going to be correct. All right, B. 2 sine x equals negative 1.5. Interesting. This question says to 2 decimal places. So as soon as we are looking at to 2 decimal places, usually what that means is we're going to have to use a calculator. So let's get into it and see what we're going to have to do. I'm going to rearrange it. Sine of x equals negative 1.5 divided by 2, and that's not going to be nice. What we could do is we could always try to turn that into a nicer little fraction. 1.5 is 3 over 2 divided by 2, so we could say that sine of x is negative 3/4, but that's not anything that relates to exact value triangles. So what we're going to have to do is we're going to have to think again about a base unit circle. Sine is negative here, our value is negative. Look again, and because sine relates to the vertical quadrants, that means that I have to be in the bottom 2 quadrants. So that means again I'm maybe going to have multiple answers. Now it says here in my question about the domain from 0 to 720 degrees. That is 2 full revolutions. That means I'm going to have an answer that is, as I work around my circle, I'm going to have an answer here, somewhere in here. Then I'm going to keep going, get an answer somewhere in here. Then I'm going to keep going all the way around, get another answer in here, keep going again, get another answer in here. So I'm going to end up with 4 answers. Now, let's have a think. How do we get the size of our angle first? Now, the size of our angle, we can just do, better write that correctly, x equals sine to the negative 1 of 3 on 4. Now, I'm doing sine to the negative 1 of 3 on 4, and the reason I'm not doing it as negative 3 on 4 is it doesn't matter. Remember, the 3 on 4 is just the magnitude. The negative we're already going to account for with these locations over here. So we're finding out at the moment, when we do this, I'm going to type it in my calculator now, sine to the negative 1 of 3 on 4 is going to give us our quadrant 1 up here, our top right quadrant position. So this says to me I'm at 48.59 degrees over here. 48.59 degrees. So the next thing is to think, where are these other positions? Well, my first angle is going to be down here, and I'm going to call these x1, x2, etc. x1, my first angle, is at 180 degrees plus 48.59 degrees. So my first angle is at 228.59 degrees. The second one is going to be over here, and in that case we're actually at 360 degrees take 48.59 degrees. So I'm going to be at 311.41 degrees. Then for these other two angles, I'm going to shuffle down, well, I'm going to move across a little bit, x3 and x4. These are just a full extra revolution away. So what that means is I could say 228.59 plus 360, and that is going to give me 588.59, and then for this one down here it's 311.41 plus 360, and that's going to give me, what is that, 671.41 degrees. Now that's not a very common question. Usually it's more common to work in radians. Alright, let's get on to C and finish this video up. Tan theta minus 1 equals 0, and we're going from negative pi to positive pi. Alright, so tan theta minus 1 equals 0. So where is tan of theta equal to positive 1? I'm going to draw my circle, and we're going all the way from negative pi to positive pi. So negative pi up to positive pi. Well, we just saw a question up here where we saw tan was equal to positive 1 when we did tan of an angle. So tan of an angle is equal to 1 where the sine part and the cos part are the same value, because remember we just saw before that tan is a combination of sine and cos. So what that means is if I want to be equal to positive 1, it's where sine and cos both are positive up here. So we're going to be at pi on 4, and it's going to be where sine and cos are both negative, so down here, which again we're looking at a couple of different ways we can write this angle. If you were thinking 5 pi on 4, it wouldn't be the worst thought to have. However, you have to look and see our domain maxes out at pi, which is over here, so we can't be at 5 pi on 4, but we have to also remember that our domain goes into the negatives. So I've got one angle that goes in the normal direction at pi on 4, and then our second angle actually goes in reverse. So this angle would be negative 3 pi on 4. So we once again have two answers. That means our angle is equal to pi on 4, and our angle is equal to negative 3 pi on 4. As you're seeing with a lot of this stuff here, this is all heavily reliant on fluency and knowledge around the unit circle, converting pretty quickly between pi on 3 being 60 degrees, pi on 6 being 30 degrees, etc., etc. You are going to need to build some fluency in the unit circle to be comfortable solving for these exact value solutions.